Historically, interacting with artificial intelligence has been, a lot like talking to the world's most brilliant yet completely immobilized encyclopedia.
Right, yeah, like an encyclopedia with absolutely zero agency.
Exactly.
Yeah.
You type a question, it prints out this incredibly articulate answer, and then it just sits there.
Yeah, it was entirely contained within the borders of a chat window.
Right. You still have to take that answer, open your own software, and actually go do the physical work yourself.
Right, the actual execution was entirely on you.
But what happens when that encyclopedia suddenly grows a pair of hands?
That's the real question.
When it graduates from simply telling you how to format a spreadsheet to literally taking control of your mouse, opening Excel, and building a complex financial model on your behalf.
It's a massive paradigm shift.
It really is. And that is exactly what we are exploring today. Our mission for this deep dive is to break down a truly pivotal week of OpenAI updates spanning March 1st to March 7th, 2026.
And it was a busy week.
Oh, incredibly busy. This week marks a definitive, fundamental shift from language models that merely talk to action models that actively do.
Yeah, we have a massive stack of sources to get through to really understand this transition.
We do.
We're going to look at desktop controlling agents, a staggering $50 billion mega deal,
A safety billion.
and the geopolitical fallout of these systems intersecting with national security.
So welcome to the deep dive. Whether you're prepping for a boardroom meeting, catching up on the field, or just trying to figure out what this means for your own desktop, we're going to break it all down. Okay, let's unpack this.
Well, I think we need to ground this in reality right away because it is far too easy to get lost in the hype cycles.
Oh, for sure.
So we're going to look specifically at the technical mechanisms introduced this week. We're going to break down the how and the why and exactly why these rapid updates matter to your daily digital life and, honestly, the infrastructure of the internet you use every day.
Because before an AI can act autonomously, it has to be able to think reliably, right? And this week, OpenAI's research division published evidence proving these frontier models are thinking at a mathematically elite, yet entirely monitorable level.
Yeah, the math paper was wild.
It really was. To see let's look at a globally released research paper published on March 4th.
Right.
The headline here, directly from OpenAI research, is Extending Single Minus Amplitudes to Gravitons.
Which sounds incredibly dense.
It does.
Yeah.
But in short, OpenAI researchers used GPT 5.2 Pro to help discover and verify a new mathematical result regarding particle interactions in quantum gravity.
Yeah, and to really understand why that matters, we have to look at what it was actually doing in that process.
Okay, lay it out for us.
Well, quantum gravity is one of the most notoriously complex, unresolved fields in theoretical physics.
Right.
It's the attempt to reconcile general relativity with quantum mechanics. And the AI in this scenario wasn't just acting as, like, a fancy search engine summarizing existing papers for the researchers. No, it was actively helping them derive non-zero graviton tree amplitudes. I mean, it was doing novel, unpublished math.
Wait, back up a second. Are you saying it's essentially acting as a co-author on a theoretical physics paper?
Basically, yes.
But how do the researchers even know it isn't just hallucinating the math? I mean, we've all seen AI confidently invent information before.
Right. And that is exactly the right question to ask, and it leads perfectly into our next source.
Okay.
To trust an AI with high-level logic, whether that's quantum physics or clicking around your desktop, you need to know exactly what is happening inside his brain.
Right.
So on March 5th, OpenAI research published another global paper with the headline, Reasoning Models Struggle to Control Their Chains of Thought.
Ah, right. They released something called the COTI Control Evaluation Suite. And COTI stands for chain of thought.
Exactly.
They tested 13 different reasoning models across over 13,000 tasks.
Yeah, a huge sample size.
And the headline finding was that these models completely failed to deliberately hide their internal reasoning steps.
Yes, and the methodology here is just fascinating. They tested these models by explicitly instructing them to act deceptively.
Like telling it to lie.
Essentially, yeah. They told the AI, solve this problem, but whatever you do, obscure or hide your chain of thought from the user.
Wow.
And across the board, the maximum controllability score was just 15.4%.
But wait, why would they even ask the AI to hide its thinking in the first place? That seems completely counterintuitive if the ultimate goal is to make these systems safe and transparent.
Oh, it's a stress test for deception.
Oh, I see.
Right, because if an AI system is capable of hiding its true thoughts while presenting a benign output, it could theoretically scheme or act maliciously without human monitors ever knowing.
That makes sense.
But because the model scored a dismal 15.4%,
Huh.
it means the overwhelming majority of the time, the model simply could not stop itself from revealing exactly how it arrived at its conclusion.
Okay, so it's like having a brilliant lab partner who is physically incapable of hiding their scratch pad.
That's a great way to put it.
Like, even if you explicitly order them to keep their math a secret, they just can't help but show their work on the page.
Right. And what's fascinating here is that this perceived failure to follow instructions is actually a massive fundamental win for AI safety.
Because we can see everything.
Exactly. As these agents gain more autonomy, we absolutely must be able to audit their decision-making process. Because their controllability is so profoundly low, we now have mathematical proof that models cannot reliably obscure unsafe thoughts.
Right.
It makes chain-of-thought monitoring a highly trustworthy, interpretable safety tool. If the model starts reasoning toward a malicious action, it will quite literally show up on the scratch pad, and human monitors can intervene.
And that verifiable transparency is exactly what gives engineers the confidence to move these models out of the research lab and into the consumer layer.
Exactly.
Which brings us to how this tech actually hits your laptop. We are taking that transparent reasoning and giving it a mouse, a keyboard, and a spreadsheet.
Yes, the action part.
Right. To see how this transparent reasoning actually gets deployed, we have to look at the flagship product launch for March 5th.
Yeah, from the OpenAI product post and developer community. The headline is, Introducing GPT 5.4 and GPT 5.4 Pro.
A big one.
The big one. This model was pushed out globally across ChatGPT, the API, and Codex. And this is the definitive, concrete shift to the action model paradigm.
Right.
GPT 5.4 introduces native computer use capabilities alongside a massive 1 million token context window.
Okay, let's talk about what native computer use actually means, because the numbers on this are staggering.
We really are.
The benchmark to watch here is called OSWorld-Verified, which tests autonomous desktop navigation. The AI is given an objective, and it has to issue mouse and keyboard actions to accomplish it.
Like a real user.
Exactly. And the human average success rate on this benchmark is 72.4%.
Okay.
The previous model, GPT 5.2, scored 47.3%, but GPT 5.4 just crushed it with a 75.0% success rate. It is officially beating the human average at navigating desktop operating systems. But how is it actually doing that? It's not just injecting code into the back end of a website.
Oh,
Right?
not at all. It is literally looking at the screen.
Like visually.
Yes. The model takes a screenshot of the desktop, parses the visual data, understands the user interface, reasons about the next logical step, calculates the exact X and Y pixel coordinates on the screen, and it executes a digital mouse click or keyboard stroke.
That's wild.
It is operating the machine the exact same way you do visually, just significantly faster and with fewer errors.
That is incredible. And OpenAI immediately aimed this capability at some of the most complex software on the planet.
Oh yeah, Excel?
Right. Also on March 5th, an OpenAI product post announced a beta native add-in that brings GPT 5.4 directly into Microsoft Excel.
Yeah.
The headline is ChatGPT for Excel and new financial data integrations. And we are not talking about a little chatbot sitting in a sidebar giving you formatting tips here.
No.
We are talking about the AI actively building, updating, and tracing errors in complex financial models directly inside your workbook.
And it isn't operating in an isolated vacuum either.
Right.
It is directly pulling live data from new integrations like Moody's and Factiva.
Oh, wow.
To put a metric on it, OpenAI ran this through an internal investment banking benchmark. This evaluates tasks like building 3-statement financial models from scratch with proper citations.
Heavy-duty stuff.
Very heavy. And the performance jumped from 43.7% with the older GPT-5 model all the way up to 87.3% with GPT 5.4 thinking.
So if you are a junior analyst listening to this, this is the exact tool that is either going to become your absolute best friend or your direct replacement.
Honestly, yeah.
It is essentially doing the workflow of a high-level investment banker. But it doesn't stop at finance. For software engineers, we saw a global release on March 4th from the OpenAI Help Center. Headline, Codex app for Windows.
Right.
They launched a native desktop app bringing their coding agent, Codex, directly to Windows.
And the key word there is native.
Why is that so important?
Well, previously, Windows developers often had to rely on cumbersome workarounds like virtual machines or the Windows subsystem for Linux just to get these advanced coding agents to run properly. So by launching a native Windows app, OpenAI has entirely lowered the friction for enterprise developers.
Okay, explain the native agent sandbox they mentioned in the release. What does that do?
Well, a sandbox is essentially a secure, isolated digital environment. Because this is a native app, it has OS-level controls.
Meaning?
That means an IT department can restrict how many tokens the agent uses, manage exactly which files it has access to on the hard drive, and safely let these autonomous coding agents run directly in a native Windows environment without worrying that the agent is going to, accidentally rewrite core system files.
Okay, that's huge for security. And while all this high-level, complex professional work is happening, they also made sure to refine the everyday consumer experience.
Yes, they did.
On March 3rd, an OpenAI product post announced GPT 5.3 Instant, smoother everyday conversations. They made this the new default for the ChatGPT interface globally,
Right.
and they specifically targeted user complaints about the AI being too preachy or overly cautious.
Yeah, the update cuts out the unnecessary moralizing refusals that frustrated so many users.
Which is a big complaint.
Huge. But crucially, while becoming less restrictive in tone, it actually became more factually rigorous.
Really?
Yeah, the update cut web search hallucinations by a massive 26.8%.
Oh, so it's just a smoother, more accurate conversation.
Exactly.
Okay, here's where it gets really interesting. If we look under the hood at the developer side, we see how they are actually making all of this financially viable. Let's look at the API pricing and mechanics.
Let's do it.
So GPT 5.4 is priced at 2.50 cents per million input tokens. But to make that work for complex agents that need to use a lot of different software tools, OpenAI introduced a new API feature called Tool Search.
And this is a brilliant architectural solution to a very expensive problem.
How's that?
Well, previously, if you wanted your AI agent to have access to 50 different tools, say a calculator, a web scraper, a database query, an email client, you had to load the lengthy definitions of all 50 of those tools into the prompt every single time you made a request.
Oh, wow.
Yeah, it burned through thousands of tokens instantly, which cost developers a fortune.
It's like making a carpenter carry their entire garage full of tools to every single job site, just in case they happen to need one specific wrench.
Exactly. It is incredibly inefficient.
Right.
Precisely. So with the new tool search feature, the model just gets a lightweight directory. It fetches the specific, detailed tool definition only when it actively realizes it needs it for the task at hand.
That makes so much more sense.
It does. And in benchmarks, this single feature cut token usage by 47%.
That's massive.
It is.
Yeah.
So whether you are coding natively on Windows or you are doing complex financial modeling in Excel, the AI is moving to where the user already works, and doing so with incredible computational efficiency.
But here's the physical reality of a model calculating X and Y coordinates to control millions of desktops simultaneously. It requires a terrifying amount of electricity.
It really does.
An encyclopedia is relatively cheap to run. An autonomous digital employee is not. And that brings us to the infrastructure making this possible.
Yeah, like the hardware side.
On March 5th, a major global strategic partnership announcement dropped, which we sourced via Perplexity. The headline, $100 billion AWS infrastructure expansion.
100 billion. Just incredible.
Expanding on their massive strategic partnership, OpenAI has committed to consuming roughly 2 gigawatts of Trainium capacity via Amazon's AWS infrastructure over the next 8 years.
And just to contextualize that, 2 gigawatts is roughly the power consumption of a moderately sized city.
A whole city.
Yes, it is a staggering draw on the electrical grid, and they are locking in access to Amazon's purpose-built silicons, specifically the Trainium 3 and upcoming Trainium 4 chips.
Okay.
These aren't standard computer processors. They are highly specialized hardware designed entirely for training and deploying AI models.
Let me ask you, this is compute basically the new electricity grid for the 21st century, because it sounds like securing the power and the chips is just as important as writing the actual software.
Well, if we connect this to the bigger picture,
Yeah.
absolutely. Compute is the foundational natural resource of this new economy.
Right.
Software algorithms are no longer the primary bottleneck. Physical infrastructure is. Whoever controls the compute capacity controls who is able to scale.
That makes total sense.
And OpenAI securing 2 gigawatts of dedicated infrastructure over 8 years is a massive strategic moat against any competitors trying to build similar agentic models.
Now, with models taking autonomous actions on desktops and consuming city levels of power, we also saw a major stress test of corporate governance this week, specifically regarding military applications.
Yes, the Pentagon story.
Right. On March 2nd, the OpenAI company blog published a U.S.-focused update with the headline, Department of War Agreement Amendment.
And for context on this timeline, on February 28th, OpenAI announced a classified deployment contract with the Pentagon, and the public reaction was immediate and severe.
Yeah, and just sticking strictly to the facts reported in our sources here following that initial Pentagon announcement, there was a 295% spike in ChatGPT app uninstalls, along with highly publicized protests at their headquarters.
Right.
In response to that backlash, on March 2nd, OpenAI amended the contract. They explicitly banned the use of their technology for domestic mass surveillance or for use by intelligence agencies like the NSA.
And importantly, they enforce these red lines through their deployment architecture.
How so?
It is a strictly cloud-only deployment. The models are not being deployed locally on edge devices.
Wait, why does cloud versus edge matter in a military context?
Because if a model is strictly in the cloud, OpenAI maintains a level of access control and monitoring. If a model is deployed on an edge device, meaning downloaded directly onto a local piece of hardware, it could theoretically be physically embedded into autonomous weapon systems or drones that operate without an internet connection.
Oh, wow.
Yeah. So by forcing it to remain in the cloud, they physically prevent that kind of embedded deployment. The amendment showcases the highly fragile balance these frontier labs must maintain. They are trying to secure massive national security partnerships while simultaneously maintaining consumer trust.
It is an incredibly delicate tightrope. And speaking of security, while humans are debating policy and protests, the AI is now actively hunting for vulnerabilities in our software.
Yes, the security agent.
On March 6th, an OpenAI product security post announced a global launch with the headline, Codex Security and Research Preview. We noted earlier that the GPT-5.4 Thinking System card, published on March 5th, stated this is the first general-purpose model with high capability in cybersecurity mitigations. Now we are seeing that in action. Codex Security is an application security agent that autonomously scans code bases, validates vulnerabilities by executing them in sandboxes, and then actually proposes patches.
And this is a major leap from how cybersecurity traditionally works.
How does it usually work?
Well, traditional static analysis tools, which just scan code for known bad patterns, are notorious for generating massive amounts of noise.
Like false positives.
Exactly. They flag thousands of false positives that human security teams then have to painstakingly manually review.
That sounds exhausting.
It is. But Codex Security uses actual reasoning. During its beta, it analyzed over 1.2 million commits.
No.
It found 792 critical issues, and because it can reason about what is actually a threat versus what is just weirdly written code, it slashed traditional static analysis noise by 84%.
Which is deeply necessary because AI is now auditing the very code humans use to build our digital infrastructure.
Yeah, it's wild.
It isn't just generating code, it is securing the ecosystem. And developers are clearly hungry for it, perhaps too hungry.
Yeah, the outage.
Right. We have an incident report from the OpenAI status page spanning March 6th to March 7th globally. The headline is, Issues with Increased Codex Usage Rate.
Yes. The moment these new agentic coding workflows became available, developers flooded the system. Immediately. A severe spike in Codex usage caused API and interface rate limit issues for users overnight. It was an official reliability incident, and it completely underscores the immediate infrastructural strain we were talking about with the Amazon deal.
The demand is undeniably there. And when you have safe, highly capable models that are backed by massive compute, that inevitably leads to one thing, massive corporate adoption.
Oh, completely.
Which brings us to the enterprise business layer of this deep dive. On March 5th, alongside the AWS infrastructure expansion we discussed, there was another massive announcement.
Yes.
Sourced again via Perplexity, the global headline is Amazon $50 Strategic Partnership and Frontier Platform. Amazon is investing $50 billion into OpenAI to co-develop a stateful runtime environment. And in exchange, they are making AWS the exclusive third-party cloud distributor for OpenAI's new enterprise agent platform, which is called Frontier.
And the technological key to this entire $50 billion deal rests on that word, stateful.
Okay, break that down for us.
We need to define what a stateful runtime environment actually is, because it solves the biggest bottleneck in AI today. Historically, interactions with large language models are stateless.
Wait, break down stateless versus stateful for me. What does that actually mean for the AI?
Think of a stateless interaction like talking to someone who has severe short-term memory loss.
Okay.
Every single time you send a prompt or an API call, the model has to process the entire context from scratch, It has absolutely no persistent memory of the conversation you had 5 minutes ago unless you take that entire past conversation and manually feed it back into the prompt.
Which takes tokens and time.
Exactly. It is incredibly inefficient for long tasks. But a stateful runtime environment fixes this. It allows AI agents to maintain persistent memory and context across long-running enterprise workflows.
So we're talking about workflows that don't just take a few seconds of typing, but autonomous tasks that take minutes or even hours to complete.
Exactly. Going back to our lab partner analogy, a stateful agent is a lab partner who remembers that 3 hours ago, you told them to exclude certain data from the experiment.
Oh, that's incredibly useful.
Right. If an agent is autonomously researching a market, drafting a 30-page report, coordinating with another AI agent via email, and then updating a central database, it needs to remember its state throughout that entire hours-long process.
Yeah, I can't just forget.
No, it cannot forget what it did in step 1 when it reaches step 10. That persistent, stateful memory is exactly what Amazon and OpenAI are building with the Frontier platform.
And we are already seeing this persistent memory being deployed in the wild. On March 6th, OpenAI published global case studies showcasing real enterprise deployments.
Yes, real companies using this.
The headline, Case Studies in Agentic Enterprise.
Yeah.
We have Balyasny Asset Management, who built an entire proprietary investment research engine using GPT 5.4. And we have Descript, who is utilizing these new reasoning models for highly scalable, multilingual video dubbing.
Amazing.
These aren't just fun little pilots or weekend hackathons. These are core operational systems handling highly complex, multimodal corporate work. So what does this all mean for the broader market?
It means we have officially shifted from pilots to portfolios.
Pilots to portfolios.
Right. For the last few years, enterprises were essentially just playing with AI. They were testing internal chatbots, maybe using it to draft some emails.
Tinkering.
Yeah, tinkering. But now they're fundamentally re-engineering their core operational processes around agentic AI.
Yeah.
It is no longer a novelty. It is becoming the foundational operational layer of the company itself.
It has been a truly monumental week of updates. To synthesize everything we've unpacked today, we watched AI transition from summarizing text to deriving novel quantum gravity math. We watched it move from giving Excel tips to autonomously tracing financial formulas and successfully navigating the complexities of a native Windows desktop.
It's just staggering.
We saw the physical reality of these systems demanding 2 gigawatts of dedicated power and the geopolitical reality of balancing Pentagon contracts with consumer trust. This was the week AI definitively transitioned from a conversational tool that simply gives you answers to a stateful, autonomous agent that takes actions on your behalf across your entire operating system.
Which leaves us with a profound societal shift to consider.
Yeah.
This raises an important question,
What's that?
If an AI can now accurately trace financial assumptions across an entire Excel workbook, autonomously hunt for vulnerabilities in complex code bases, and independently navigate a Windows desktop faster and better than the average human, what exactly does the definition of an entry-level job look like 12 months from today?
That is the multi-trillion-dollar question you have to ask yourself. We started today talking about the difference between an encyclopedia and an employee. Well, this week, the encyclopedia just got its own company credit card, its own desktop login, and a desk right next to yours. Thank you for joining us for this deep dive. Keep questioning, keep learning, and we'll see you next time.